Springtails are tiny bugs just about the size of a grain of sand. They live on all 7 continents, but they tend to prefer humid, forested areas.
You'll sometimes see them as you're walking through the woods. If you disturb them, they'll jump in a seemingly chaotic cloud. But there are a few myths to dispel here. First, springtails are not insects. They were originally classified as such, but we've gained information about them. They've been reclassified as a kind of arthropod, like pill bugs. The other thing, those jumps are not chaotic. Springtails have a high degree of precision and control over the way they take off and the way they land.
There are 2 parts of the springtail that are key to understanding how they move. You see them here. That's the caulophore, which is a tube-like structure on the springtail's belly. It collects a droplet of water as they take off, and a farcula, which is a forked tail-like appendage. It snaps with a lot of force, propelling the bug into the air.
A researcher who recently joined the University of Maine faculty just published a study demonstrating their remarkable ability to jump. Victor Ortega started studying springtails while at the Georgia Institute of Technology when the pandemic forced his family outside.
Our producer, Krista Rollins, spoke with Ortega about why these springtails developed their springiness.
But the amazing thing is that they are the food of everything. They are the food of ants, the mites, you can think in water striders in the water, fish. So that's why they need to be ready for escaping, right? So that's why they have this amazing control of landing to be ready to escape, because everything eats springtails. People said in the literature that these are not controllable because they are exploding in the air, like a popcorn, and looks like they have no control. But I put the springtails jumping in the water. Oh, surprise, they are rotating and they are stopping in midair by curving the body and landing on its feet. When they are taking off, they are jumping vertically. If they are, imagine if they have this is the water interface. If they have the abdomen close to the water interface, they are jumping vertically. But if they do something like this, put the abdomen far away from the water, so the furcula has less room to impact the water, and so they are moving horizontally. And I demonstrated that they are moving horizontally at the same pace than water striders.
I thought I might try and share my screen and we could watch one of the videos that you provided.
Sure. And here is the jumping, and you can see the water droplet actually in the caulophore. And this is a remarkable scene because you can see the rotation, and in that exactly moment, it's curving the body, closing the furcula, and it's landing on its feet.
Boom. That's
like better than Olympics, right? Like a 10. But here you can see the body is curved, it's landing on its feet, and it's just in maybe less than 10 milliseconds, they are just attaching to the water and they are ready for the next job.
Yeah,
and they are producing these waves, Yeah, they stick. Here the springtail has a dry caulophore, and because it's dry, there is no water, and that's why it's not attaching to this plastic container.
Okay.
So having a water droplet is essential for attaching. This is in the wind tunnel. The flow is blowing up, and you can see this guy just going with the wind, just curving. And here is one on rotation. So he's jumping, he's curving the body, it's stopping all the rotations, and it's getting stable. But this is different. You can see that he wants to go down. So he just make a small bowl, and he goes down like an acrobat. And I think the star of the show is the springtail, because there is not so many papers about these little guys, and they are fantastic. So they are the star of the show.
There is a lot more to this. You can probably tell Victor Ortega is pretty excited about his research. He says the springtail studies aren't over yet. He does plan to study some of their cousins, pretty common here during Maine winters, snow fleas.
Now, Ortega says this research will be useful in the development of jumping robots, which may be useful for travel on the moon and Mars. And he's worked with other researchers on actually making those robots and figuring out the math of how they move.
See a lot more of those, of course. We also have to share that this drawing was made by Victor's daughter, Hatsley. She was simply smitten by her dad's research and had to draw the springtail in action.
Really cool.